Do you have any specific questions or any particular questions on a specific homework assignment, or you just want um, a general overview?
Yes, I do just want a general overview. I'm actually trying to sign in now.
Okay. Because this week's topic, let me check it.
Yeah, we can just start from this week, basically.
Well, I mean, it's hard for us to, we are on week 6.
Thanks. Yeah.
Okay. So we are talking about normal distributions this week. So I take it that you have been following what we have been doing, because normal distribution is a special member of the class of distributions, probability distributions. And normal distribution is a special member of that class of continuous distributions. You have discrete distributions. You have continuous distributions. All right. Now, the basic properties of distributions are the same. That is to say, the sum of any probability distribution is equal to 1. It's always that, whether you're dealing with continuous distributions or with discrete distributions. Okay, the sum of the probability distributions is always equal to 1. Now, the difference is that in normal distributions, in continuous distributions, you do not have the probability that a specific event at a point will occur. For example, what is the probability that x is equal to 3? You don't have it in continuous distributions. In probability distributions, you can ask, what is the probability that x is equal to 3, or that a particular value will be so. For example, if you were dealing with binomial distributions, you say that if you try 10 times, for example, if you try 10 times, what is the probability that you will succeed 3 times? All right. What is the probability that you will succeed 4 times? So you can find P of x equals 4. All right. Now, for example, let us say that the probability of jumping across a pond, a person jumps across a pond, what is the probability that you will succeed in jumping across that pond 4 times? You can find that in discrete probability distribution, but in continuous probability distributions, you cannot do that. Now, the normal distribution that we are talking about is a member of the class of probability distributions, and I'm going to see if I can give you a general overview, and then you can ask questions. There's also, what do you call it? There are YouTube videos. Have you looked at them?
Yes, I've looked at them.
Okay. Those YouTube videos can explain things also. You should watch them, and
Okay.
they will help you to understand whatever we are talking about. Now, I'm going to pull up I'm going to pull up a set of PowerPoint slides. Okay. Okay, are you seeing my screen?
Yes, I can see your screen.
All right. Now, before I begin to run the PowerPoint slides, um, let me see if we can understand what we are talking about, and maybe examples will help us to clarify things. Okay, we were going to have a hard stop. You came in late. We're going to have a hard stop in about 20 minutes. So let's see what we can do. You can arrange a special session when it's more convenient for you, and I'll be glad to go through some examples with you. Okay.
Okay.
Yeah, you can just give me a couple of like days and times, and then I could come back on Zoom and we can do a special session. Okay.
Okay,
Nevertheless,
thank you.
now let's talk about normal distribution. Normal distribution, like I said, is a special member of the class of continuous distributions. Now, the standard normal distribution is based on an imaginary random variable called z, like in zebra. And this imaginary random variable has an average value or a mean value of 0 and a standard deviation of 1. Now, the shape of the standard normal distribution is symmetrical, looks like a bell, okay? It's based on a probability density function, which we don't have the mathematical foundation to do in this class, but you can see that the frequency distribution of the values of a normal distribution look like a bell, okay? It is symmetrical, and the value, the mean value of z is 0, centered right at the tip of this curve down below here. So it has a mean value of 0. So the values of z go from minus infinity to plus infinity, and in the middle of it is 0, which is the mean value. There's a standard deviation of 1, okay? All right, so this is the mean. So the center here has the value 0, has a standard deviation of 1. And so if you go from 0 to the right one step, one standard deviation, the value of z will be mu plus 1, okay? And if you go one step to the left, the value of z will be mu minus 1, okay? Standard deviation is 1. All right. Now, we're going to use this to solve problems about variables that do not have an average value of 0. But let us first of all understand the concept, okay? Okay, so this is what is explained in this other slide, okay? It is symmetrical about its mean, mu, and the highest point occurs at x equals mu. Like I said, for the standard normal distribution, that value is 0. Okay, now, if you look at the standard distribution, how we use it to find the probability that a particular variable will have values between one point and another. Say, what is the probability that a student who comes to school every day or on any day will arrive from wherever they are between 25 minutes and 45 minutes, okay? We use the standard number distribution to answer such a question based on data, based on, say, records of students arriving to school. And we calculate the amount of time 1,000 or 1,000,000 students come to school. We we calculate the average, and then we ask ourselves, what is the probability, what percentage of students arrive school between 20 minutes and 35 minutes, between 20 minutes and 55 minutes. And how we calculate that percentage is based on the distribution that is normal, okay? And so when you get information, we calculate the standard deviations so that the average student arrives at mu. Okay, that is the average time is mu. And then one standard deviation to the left and one standard deviation to the right. What is the probability, what percentage of students arrive between, say, 20 minutes and 30 minutes? Okay, and we use the area under the curve to find out that probability or that percentage. So in a standard normal distribution, we see that the percentage of students that come between the average and one standard deviation to the right is 34%. The percentage of students that arrive between the average and one standard deviation to the left is also 34%. How do we get that? Okay? We get that from a calculation of the area of the normal distribution, which we are going to use the table of normal distribution to calculate. See if we find the table. I'm going to my table. Just give me a minute. Let me get the table.
That's fine. I'm following you.
You're following me? Okay, but I just want to show you what the table looks like.
Okay.
Right, I'm pulling up the table. All right, so here is the table for the standard normal areas under the normal distribution. So let us say we are looking for the area. What is the probability that Z will have a value between 0 and 1.96? Okay, which is 1.96 deviations away from the mean. The answer would be, you see, we go to 1.9. You see 1.9 here?
Yeah, I see 1.9.
Okay.
One standard deviation will be 0.4719.
No. 1.9 standard deviations will be, that is to say, what is the probability or what percentage of values of Z will fall between 0 and 1.9? It will be 47%. 0.4713. You get the idea?
Okay, I see.
Okay. What percentage of values of Z will fall between 0 and 1.96? It will be 0.4715.
47. Okay.
Okay. Now it could go to the left or it could go to the right. The same area will be covered. You get it? Because
Yeah,
of
it would
this,
just be a negative.
it will just be a negative number. Okay. So that is how to read off the probabilities under the standard normal distribution. All right.
So let me ask you a question. For
Sure.
this, this table, we need to always use this table? No, right? Because I feel like in a different class, I was able to find the mean using different numbers.
Well, we're going to get to that. Okay.
Okay.
You will always use this table to find the area under the curve and the probability distributions. Okay.
So should I take a copy of this?
Yes, you should have a copy of it. It's uploaded in the syllabus. It's
Okay.
uploaded. It's uploaded
Okay.
on the site, on the website of the class. It's there. It's available.
Okay.
If you cannot find it, send me an email and I'll send you a copy. I'll send you this copy.
Okay.
Okay. All right. So we're going to go back then to our PowerPoint slide. Okay, so if you had looked under the table there, you would have found out that the probability that Z will have a value between 0 and 1 is 0.3413, or between 0 and -1 is also 0.3413 because the curve is symmetrical. All right, so having said that, okay, what is the area under the standard normal curve? The left of Z equals minus 0.38. If you look at it, if you read off the table, okay, the Z will equal to 1.25. And so what is the probability that X is greater than 1.25? Okay, so if you look at that symmetrical curve and you slice it right in the middle of it, the area under one half of the curve is 0.5, and the area under the other half of the curve is 0.5. So when you join the two areas, the area of the normal distribution is 1. You get the point?
I kind of sort of get it. I'm
Okay,
trying to.
let's suppose we want to calculate what is the probability that Z is greater than 1.25, right? Let us find out. I'm going to stop this share and bring up the normal distribution. You should write down what we asked about. What is the probability that Z is greater than 1.25? Okay. Now, if you think about the curve and think about greater than 1.25, all right, let's bring up the curve again. Right, I'm going to go backwards to show you what we mean by area greater than 1.25.
Okay.
See the curve? Have you seen the curve?
Yes, I see the curve.
Okay. Suppose we draw a line here. See where my cursor is? Right? From 0 to 1.25, right?
Right.
Okay. Instead of doing a slide, excuse me. All right, so I'm looking at this here now. Suppose I'm able to draw right. You see this? You see the curve right here?
I see the curve. I'm looking at the curve.
Good. You're looking at the curve.
Let
What is the probability, right, that z has a value greater than 2? You see where 2 is?
Yeah, it will be 0.0125. 0.0215, excuse me.
Very good. What did you find? You find the area that is greater than 2,
Right.
right? Good. What is the probability that z has a value between 0 and 2?
I would have to add 0.3413 and 0.1359.
Exactly.
Mm-hmm.
You get the idea? Okay.
Yes.
So that is when we ask what p of x greater than 2, we measure only the area after 2. If we
Right.
ask what is the probability of z having 0 between 0 and 2, we add these two areas.
Mm-hmm.
Okay? All right. So this is what we're going through. So now let's look at a practical problem. Okay? By reading um,
So that is going to be I guess to the left of the curve.
that to the left, what is the probability that z is, where z is minus 0.38? Then you look at the area of the curve on this side,
Mm-hmm.
which is going to be between 0 and minus 1. Am I correct?
Mm-hmm. Yes, that's
Because
correct.
because
It falls in
3.38,
between there.
yes, it falls in between there. Okay, so you are following what we're talking about. Let us see if we can solve a practical example. And how do we solve practical examples? Okay. We want to pull up a practical problem and see if we can solve it.
Okay. Question for the practical problem, do I have to pull up that chart?
Because you would have to convert practical
Okay.
numbers, you have to convert practical numbers to z values.
Okay, so I have to look for the chart.
Yes. Like I said, just send me an email and I'll send you this chart that I have, but it's there in your syllabus. Okay. Let us say a radar unit is used to measure the speeds of cars on a motorway. The speeds are normally distributed with a mean of 90 kilometers and a standard deviation of 10. You see that?
Yes, I see it. I'm sorry. I keep muting my phone because of my children, but I'm following.
That's okay. I know about kids a lot. Okay. So the speeds are normally distributed with a mean of 90 kilometers and a standard deviation of 10. So we have numerous cars, 1,000 cars, 1,000,000 cars passing through this road, and we measure their speeds. We take the speed of each one, okay? Then we calculate
Mm-hmm.
the average speed, and that average comes to 90 kilometers an hour. And the standard deviation, that is the distribution, is about 10 kilometers per hour. Okay, that is distribution between some below 90, some above 90. Okay.
Mm-hmm.
What is the probability that a car picked at random is traveling at more than 100 kilometers an hour? So you can see here that more than will be, we take the point of 100, and then we, how do we write that? Okay.
So if we are looking at a bell curve,
So we
right?
are saying, what
In
is
the
the
middle.
probability that
Mm-hmm.
x is greater than 100. That is what we're going to be looking at.
Okay.
Right? Okay. So let me if I can. So we are looking at this. So,
Yes, I'm here.
all right. So we are looking at
The mean will be
one.
90, right? And we'll go up
Yeah.
10 for each one.
Okay, the mean is 90.
Mm-hmm.
Okay. So we are looking for this area here.
Right.
All right. What is the probability that X is greater than 100? So in order to solve this problem, we know that this curve here, the area of this one side is 0.5, and the area of that one side is 0.5. Is that correct? Okay. So,
1 second. I do get that.
okay. This curve, the probability distribution curve, has an area of 1.
Mm-hmm.
If you slice it exactly in the middle of it,
Mm-hmm.
this half left side has an area of 0.5.
Okay.
This other side, the entire side, right side, has also area of 0.5. So the two
Mm-hmm.
areas will be 1. Am I correct?
Right, that's correct.
So what we do is we standardize these regular values to z values. And the standardization is by calculating z equal to x minus mu, the mean, divided by the standard deviation. You get it?
Yes, I understand.
Okay. And so in this case,
So
z will be what?
I don't know. I'm assuming first we have to find the standard deviation.
We already know the standard deviation. We say it's
And you
10.
said it's okay.
It's there, it's 10. So it will be 100
See.
minus 90 divided by
And then that's
10.
how you get Z.
And that's how you get z. 100 minus 90 is 9 divided by 10 is equal to 0.9. Am I correct?
Mm-hmm.
Okay. 0.90.
Mm, you said 100 minus 90.
Yes, which is the mean.
Isn't that 10?
10 divided by 10 divided by 10 is 1. You're correct. Ah, so that's why it's good to have somebody that understands what they are listening to. Where is the eraser? I have a
Look
heartbreak
at the
in the
purple
next.
one.
The purple one? This
I
one?
think so. No, that's red. To the left.
That's,
Yeah, that
yeah.
might be the eraser. Yep,
Yeah,
eraser.
that is the eraser. The professor has done a bad math.
That's okay. We're human.
1.00. Okay, so what it simply means is that the z value between 90 and 100 is 1, right?
Mm-hmm.
So then that means that here the probability P of x greater than 100
Mm-hmm.
is 0.5 minus, what is the probability that z is between 0 and 1? We saw it to be 0.3413. Am I correct?
Yeah.
So
Let me see if I pull
we
it up.
calculate this area and deduct it from 0.5 because we're looking for only this side. This whole right side has an area of 0.5. Am I correct?
Yes, I know that much.
Okay, good. So if we find the area between the mean and 1, between 0 and 1, which is 0.3413 from the table, right?
Yeah.
Remember that from the table. You
Mm-hmm.
want me? Okay.
I
So if
have the
we sub,
table pulled up. I have it pulled up.
okay, so look at from 0 to 1. See that the area is 0.3413. This is 0. This is 1.
Mm-hmm.
If the area here, the area that I marked with asterisks, if that area is 1, I mean, if that area is 0.3413, that means that from this point to the right must be 0.5 minus 0.3413. Am I correct?
Okay, so with the point five, okay. So just to reiterate what you said, point five is the whole right side. So
Precisely.
you're subtracting the area that we know from the chart, which is the 0.3413, and that's how you're getting the mean of the other side.
Now you're getting the area
The
of the
area,
other
I'm
side.
sorry, of the other side, excuse me.
Yeah, that's fine. Okay, that's how you're getting the area on the other side, which is what percentage of vehicles have speed more than 100. So that will be 0.1687.
Mm-hmm.
Okay, that will be 0.168. So 16.87% of cars will be speeding above 100.
Okay, so I have a question.
Sure.
All right, so we knew looking at the problem that we were trying to find the area of cars that were greater than 100, right? So
Yes.
we wrote down the equation of probability x is greater than 100. And then we
Yes.
used the equation to find z. Once we
Yes.
found z, what do we do with z?
Is Z, it means that a Z falls between 0 and 1. That is this Z that we calculated.
Yeah, so I see the equation, but once we went to the bottom, which you wrote here at the bottom, the 0.5 take away the 0.3413.
Okay.
So, all right. So basically, what we did when we found Z, we take what
Okay.
we find with Z, and then we go to the chart.
Yes.
Got you. Okay. And then that's how we knew to use the
1.
0.3413.
Absolutely.
Okay.
Absolutely.
Okay.
Like I said, I'm going to have to break it, but make an appointment with me and
Okay.
I will come back here and we'll solve a couple of other practical problems.
Okay.
Okay? Now
Uh huh.
your presence have been very useful. I'm going to post this for everybody to benefit. I hope you don't mind.
Okay.
All right, so I'm going to break it
Mm-hmm.
because I have to go to another meeting.
That's fine.
But make an appointment,
Mm-hmm.
and then I will make a special time for you. All
Okay,
right.
Professor. Thank you so much.
All right.
You have
So
a good night.
thanks. You too.
All right. Bye bye.